Hi, everybody. This is Zeke, and thank you so much for continuing to be interested in Git. What we're going to talk about in this segment are what a commit is and what we need to do in terms of understanding their value and how to document things in Git versus things in our code. The segment that mattered right before this one would have been the one that describes branches. So it's useful that you watch that first to become familiar with the idea of branches. I did a small commit there to kind of overview what that was about. But in this segment, I'm going to talk about branches, show what they do, and really cover what the Git commit task and action is so that you can understand how it relates to branches and what we're trying to accomplish with it. So let's look at our GitHub desktop, and we're looking at the repository called SASGF example 1. I'm actually going to toggle to the other one called SASGF example 2, just to show you how quickly we can switch between different projects. Even another one that I have, and I can see that on this branch, on this repository, in this branch I'm at, is called ZT update first. I have a main branch. It just did a fetch for itself here just in case, but I'll do another one in case I wanted to do some work to see what's going on. But I'm going to go back to my SAS Global Forum example 1. And when I click on whatever branches are there to see where to start from, I like to see and make sure that everything is where it needs to be, the branches that I might be interested in, for sure the main branch, other branches that I might see or be interested in. And before I do any work, I recommend we pull or fetch whatever the remote repository changes or updates might have. After I do that type of action, then I feel safe to go to a branch I might be working on, or check something out, or look at something and get refreshed as far as what I was doing. So the reason why commits are important is because they are actually what we leave behind for ourselves in terms of notes or comments about what we were thinking of, what we were doing, what we did, and what took place. So Git commits and the comments that are related to that are very, very helpful to us, but to our future self, and then to our colleagues or other people that are interacting with that repository. Now, remember, in the example where I highlighted what branches were about, we had cloned or created a copy of the main branch into a branch called some branch. And I had made a minor change there to actually give you an example of how that would work. And I created a commit. I created a commit to actually document what that was about. Okay. But if we look, GitHub Desktop is telling us that we have an option to publish this branch. So what that means is if we look at our GitHub repository for that specific project, let's find it, and I'm going to share it with you right now. If we look at that repository via GitHub, I have where the repository is, and then I have a place where I can toggle on the branches. There are no branches, right? The only branch there is that this remote repository knows of is the main branch, because my GitHub desktop is telling me I have these branches on my desktop, on my laptop, but I haven't published them or pushed them. I haven't connected those and copied them to the remote repository. When I do that, it will take that branch and those commits and put them into my remote repository. So now here, if we refresh the screen, we have two branches there, and a pop-up shows up that some branch had recent pushes less than a minute ago. So the GitHub cloud folder where the repository is at is starting to interact with me and telling me what branches are present, and I can toggle to that branch, and you can see the difference here. That line exists, and then if I toggle back to my main branch, it doesn't exist there. That's because I have two branches. And where the commit comes in to play is I can actually click on the branch that I'm evaluating and actually see the commits that relate to that. Now, this is very reminiscent of what we saw here, where we can see the differences. And so the GitHub repository is showing me the same. So when we commit something, Git uses a unique identifier in order to track that commit. That is the element that allows us, and it's a very long digit, very long set of numbers that, for this purpose of an introduction to Git, we don't want to get into too many details, but it's basically the unique identifier that Git as a database uses to let us toggle between the version we're interested in, either before or after. And so that's why in some parts of the conversations that I have with people, I describe Git to me as almost a time machine. Let me explain why. The initial commit looked like this. This is back in time 3 hours ago when I first created that repository and initiated it. And so Git assigned it a unique ID, and it's very long, but we're only seeing about 6 or 7 digits worth here. And then about an hour ago, I updated that one readme.md and made a change to it, and I committed it. I made a comment as to what that change was about, and Git assigned another unique identifier here. Again, it's about 35 or 40 digits long. I forget how long it is, but it's unique. It's distinct to that repository. There should never be another one. Otherwise, there's some corruption in the Git database. So if you look on our GitHub repository on the web, those are the same unique digits that are part of that branch. And so as we add more changes to that branch, as we make more progress in the code that we're working on, we'll see more commits. So let's actually do some of that right now. Let's go back to where we can actually, do some additional work on that. I'll walk you through that. So I recommend always to fetch, just in case, before you get started, if there's any change that you need to be aware of from our remote repository. And I'm going to open up the work that I have, and I'm going to create a new folder. And then inside that folder, I'm going to create a text file that I'm going to turn into a, basically like a SAS code. So this will be monthly report.sas. And I'm going to open it and make some quick edits. And I'm going to save that. And so what GitHub Desktop will do now is it'll notice that that's been changed. It is distinct. It understands that it's a difference from how it was just a short while ago. And so what I want to do is I'm satisfied with that code. I'm okay with it. And then somebody tells me that I need to change something else. So I'm going to go ahead and make an additional change. I'm going to go ahead and create an addendum or some other kind of additional document for it. I'm going to create a README. I'm going to create a SQL program of some sort. So test.sql. And I'm going to save that. And so now GitHub Desktop will alert me that there's another change inside of that repository under that folder where Git is managing things. And so I'm happy with these changes. I want to commit them. Although I've saved them with my text editor, they are saved in the file or operating system. To Git, we're not done. We haven't made the actual action of saving or committing those changes to the Git database and actually including them in our branch correctly. They are part of the branch. If I tried to switch branches right now to some other branch, I would get this warning. It would ask me, are you sure you want to do the action that you're trying to take of switching branches? We can switch branches and leave that uncommitted work in kind of a temporary state, or we can mash up all that temporary work that you did, the things that I did under monthly report and test SQL, we could mash them together somewhere else. You don't often want to do the actual bringing of changes into another branch without a merge. That is technically kind of like a sloppy way of doing it. So I'm going to cancel this because I didn't want to actually complete that action. I wanted to kind of highlight the warnings that you would get. What I want to do is I want to make a statement, a comment when I save that describes what I was up to. So created monthly report and test SQL. My manager requested this change via Jira ticket 123, and it was for XYZ project. At this point, I recommend people be as verbose or as informative as possible. And so it doesn't have to be a lot of sentences, but it should really be useful to what you're trying to describe. There might be got an email at 1 p.m. approving the scope of work. And so now when I commit this, it will actually associate those changes with an entirely new unique identifier and my comments. But again, now GitHub Desktop, which I always describe as a Git traffic and a Git action manager, now it's actually telling me there's more commits that I can push to the remote. So look at our remote repository. Our remote repository, if we refresh this, has that sum branch, and it has recent pushes of 8 minutes ago. And if you look at the actual number of branches, it says there's 2. There they are, the main branch and then the sum branch. And the sum branch only has just that one updated change. Look at the most recent commit. And if we go into here, it's that 816 something from an hour ago. And you can see this is showing there's only 2 commits. Now look at our GitHub repository on our desktop, and you can see that there's 3 of them here, and the most recent one, this is the oldest one, this is the one that looks like that matches up to our remote repository, and this is the one that we just made a few minutes ago with 2 changes, and it shows here a new and entirely different distinct identifier. We have to synchronize that. We have to push that up so that it actually reflects that in our remote repository. Until we do that, if we don't do that, it's almost the same as if we haven't saved our work. So a commit has 2 pieces to it. The first one is to actually commit and describe the changes you made on your local machine, wherever you're making those edits. And the final action is really to push it to wherever your remote repository is being stored, so it becomes part of that team repository. So we're going to go ahead and push that. And so I see no errors, I see no issues, but I start to see this button, and I think you've probably noticed it as well, pull request. We're going to talk about that in the next segment, but let's look at our GitHub repository. Let's go back a step here so we can refresh it. Now the indication shows that some branch had recent pushes less than a minute ago, and there's that counterpart, right? Compare and pull request. And again, another segment will describe what that is. But let's look at our branch and see what the commits are that we just saw take place. So if we go to some branch and look at it, we can see that there are commits that it's ahead of the main branch. And we can look and see that 2 minutes ago, this unique identifier or that commit was made, and there's been a total of 3 commits on this branch. And if I want to see the chronology, the history of this branch within this repository, I can start to see what that is. I can start to see how this was done and what it was for, and I can click on this and actually go to see the details behind it. My manager requested this. Remember what I just typed up? And I can see that it's part of this branch, and I can see the 2 different files that were changed or modified. And what's really cool right here is these little boxes, at least via GitHub, indicate the number of changes, either additions or deletions. So it kind of gives like a red and green scale of, did you add lines, or red, did you remove lines? In some subsequent examples, we'll be able to see that. But do you remember how I mentioned that our commits show these really crazy long digits? So in some places, it's really condensed because we don't need all of the 40 digits or so that are part of that commit SHA. The actual technical name for them is SHA, and I forget what the acronym stands for, but we don't need to worry about all the digits. We need to worry just about a handful, usually 6 or 7 digits, to be able to differentiate it because they are distinct. So some branch is now in a state where I can evaluate it, I can check it out, and if I use some of the features via GitHub or even Bitbucket, I can make comments here and actually indicate, not just to myself, but even to my colleagues, what I think I want to do next or what I want to change or what I want to evaluate. I can leave comments for somebody to start to evaluate my code and maybe check it out for me and give me some pointers as to where to go next. And so let's back up a second. We have two branches, the main branch, which is a team branch, and the only way we want to make changes to that is via a controlled merge, something that somebody approves. And we'll talk about that in a later segment. And then we have our sum branch, which is just some branch that we need to do some work on. And so we are now in a state where we've made a commit. We've done it with some comments as to what the commit is about. And our next steps are to actually do pull requests to actually continue that process of merging that branch into the main branch. So if you want to review what commits are, again, commits are that we've made changes to our code. We're going to save them with comments and a history, a log of what that was about using the commit action from Git within the GitHub desktop. We can do that via the command line, but this presentation is meant to show in a very user-friendly way with this user interface of, GitHub desktop, what the commits look like, and then pushing it up to our remote repository so we can continue to the quality control or the review process before we do a pull request and merge it to something else, or just approve it that it's in a finished state. So stay tuned for our next segment.